Good morning, everyone, or good morning, or good afternoon, depending on where you're dialing in from. Thank you for joining us today for today's webinar. My name is Mark Borbis. I'm the VP of Product Marketing for NetCo. And today we're going to talk about EMV Monitoring and Analytics, which is a pretty hot topic these days, especially given some of the transitions that are happening in North America as well as in the rest of the world. But today what we're going to talk about is how to handle fraud, how to keep transactions moving, and really to understand the EMV issue in a little bit more detail. Now, I'm sure anyone who's embroiled in an EMV project, whether you're at the beginning or getting close to what might be the end, it's always this question of how do we know when we're done and how do we measure how far along we are. And it's difficult because we want to get into this world where every single device and every single card is EMV capable and processing an EMV transaction. But the reality is there's always going to be this complex interplay between entities that are capable or not capable. And so really our goal is to figure out, can we get as many devices as possible and as many transactions as possible interacting together successfully. So what I want to introduce is this notion of peak EMV. And it's the idea that not that you've hit perfection, but that when every transaction that should be processed as an EMV, in other words, it's coming from a capable device using a capable card, actually does process that way. And so that's the new notion I want to introduce here, is that it's not about getting 100% EMV across the estate. That would be great. That's what we're all aiming towards, but it's going to take a while to get there. But how do you get to that peak EMV where at least if a transaction should be an EMV, it is going that way? So that's what we're going to spend our time talking about today. And the question is, how close do you feel you are to that point of peak EMV, where every transaction that should travel as a chip transaction is actually traveling that way? And let's talk a little bit about why that matters. The reason that it's so important to measure how close you are to peak EMV really comes into two different avenues. One is in terms of fraud losses. So as we know, the whole reason that we're shifting towards using chip or chip and pin technology is to minimize the losses that are happening in the magstripe side right now. So it makes it much harder to skim cards, makes it harder to use counterfeit cards in combination with malware to compromise systems. There's also a new type of thing that we're seeing now as some of the merchant estate has yet to transition over. We're seeing people take their cards to merchants that they know have non-chip enabled devices, making a purchase and then subsequently complaining to the credit card company that they didn't make that purchase. And so it's called friendly fraud, which is a little bit like friendly fire. It still has an impact because to the retailer, you're losing the goods as well as you're bearing the cost of a chargeback from your processor. So basically what we're seeing is that there's this window, obviously, where there is still some magstripe usage out there. And the wider that window is, the more effort there's going to be to try to commit fraud using that particular avenue. And so what we're trying to do is close that window as quickly as possible through the EMV shift. But to know that there's going to be a lot of creative fraud and hacking attempts directed specifically at the magstripe solution over the next few years. But there's also a cost structure element to this as well. I think most of us who have embarked on an EMV project know that we're making a very heavy upfront investment, and the payoff or the return on that investment is to gain fraud savings. And so it's really important that as we make that investment, we're able to take as many transactions as we possibly can using the new mechanism, so that we really are gaining fraud savings. We're reducing the number of magstripe transactions. We're reducing our fraud exposure. And so getting it right really does matter because it will affect our cost structure. We're kind of in this difficult in-between position right now where we've invested a lot in a new technology, but perhaps aren't yet seeing the benefits because there's still so much magstripe activity out there. The other element of it is probably a lower cost element, but still important, is that many banks are maintaining parallel processes. Obviously for issuing or replacing cards, you may still be issuing both magstripe and chip-enabled cards. From the maintenance, the system maintenance, the diagnostics, even the technology standpoint, you may be maintaining two rails still to handle both card types, and that has a cost associated with it. Often it's a soft cost in terms of it takes longer to diagnose problems, or you got different tool sets and people need to be trained on both, but there is a cost and an inefficiency in maintaining that parallel process. And then, of course, we're dealing with chargebacks, and chargebacks change a little bit in the EMV world, because even though the liability is shifted, we still need to be able to track down the transaction, prove that a chip or a chip and a PIN was used in that transaction, and that creates some new requirements around how we manage these chargeback issues as well. I've got a little quote on the bottom here that I think reinforces this notion of why peak EMV matters. Beyond the $4 billion in fraud expected this year, and that's this current year that we're just finishing up, there'll be as much as 10 billion would be all right, in fraud committed between now and 2020, because there's this window of opportunity for hackers to cash in on credit card data from magnetic stripe cards. And so, again, the whole notion of peak EMV is trying to get as many transactions as you can, or that should be traveling as EMV, so that you're reducing that fraud window, reducing that attack surface as much as possible, and getting as much return on your existing investment in EMV as possible, as early as possible. So with that, I'm going to push the first poll question here, and let me just shift over there. And our first poll question is, in your environment, what percentage of transactions that should go EMV don't? So we're looking at trying to understand what your potential error rate might be here. You know, is it greater than 10%? Is it 5 to 9? Is it 2 to 4? Is it less than 2? And I'll let those votes come in, because what I've seen is that a lot of whether it's banks, issuers, processors, you've had to do some somewhat unnatural things, I guess would be the nicest way to put it, to make sure that EMV is working. You know, you may have had to clamp some new code onto legacy systems. You may have had to add new systems that interact with legacy systems in different ways. You may have had to do some interesting pushes to try to get devices rolled out in the field. You may have error rates even at the hardware level. And so it's a complex interplay, and trying to figure out whether all the transactions that should go EMV are is kind of an interesting puzzle here. So I'm going to let the results keep rolling in here. And obviously, it may be that you don't know, because this is a hard thing to track as well. And there's certainly nothing wrong with that in terms of really understanding what your error rates are. And that's something we'll spend some time talking about later in today's presentation. All right, I'm going to go ahead and leave this poll open for about another 30 seconds. If you're not seeing the poll, just scroll down on your screen. It appears down below the slides that you may be looking at. So it might be sort of hidden if you're looking at this on a little bit smaller screen. Okay, so far, what I'm seeing is the largest chunk is people who figure their error rates are over 10%, followed by a bunch who don't know. That makes sense. So between over 10% and don't know, we've got the majority of people today, and then it sort of breaks down. And for those of you who are less than 2%, congratulations. You've obviously been moving on this process for a long time, and you have some good processes in place. So that's great to see as well. I'll leave the poll open for a couple minutes. Actually, what I'll do is I'll pause this poll now. We collected a good chunk of data here. Thank you very much for that. Okay, and with that, we're going to go back to the slide view. So I think part of the reason that we saw the results that we did in terms of error rates on that last poll, and why it's so hard to get to peak EMV, comes down to the anatomy of an EMV transaction itself. It is more complicated than magstripe, and it's complicated in three ways that we've seen out there in the field. The first is on the actual initiation of the transaction. So there's more happening between the card and the device locally before a transaction ever gets formed. The terminal and the card are negotiating which applications it is that they're going to use. You can have multiple applications running on the card. there's both an element of the chip verification as well as the cardholder verification. There are instructions that can get passed both ways here to block or unblock a card or reset the number of PIN attempts. And we're also making sure that the PIN number, if it's entered in, can actually be checked locally against the chip here. So there's some ongoing work that's happening between the card and the terminal itself. And then there's a risk management element here too, where the terminal and the card are actually negotiating to see whether a transaction can be approved offline if there's issues, and what that floor limit is, and some of those aspects, so if there's a local stand-in notion here as well. So although we see most EMV transactions processed as online, there is that offline potential here, and that's part of the process. And of course, all of that adds to the overall transaction time as perceived by the customer. So this is something where, all this is happening back and forth, and it may be resulting in a 1 or 2 or 3 second delay to what a customer may typically see with a magstripe transaction. Now, the transaction processing itself becomes more complicated as well. There's a decision between, are we doing online or offline, which still happens in the magstripe world as well, but there's a bunch of different options with an EMV card. Are we doing offline with local PIN verification? Do we do PIN verification over the wire? Does the whole transaction travel over the wire, et cetera? One of the big changes too is that there's a new data block that travels in an EMV transaction. It's element 55. It's a randomized block that contains a lot of data about what is needed to authorize the transaction, and it's randomized to make it harder to intercept on the way and know where to spot particular fields. But it also adds to the overall size of the message. And so we're seeing cases where customers who are trying to run EMV transactions over lower bandwidth connections or even dial-up are seeing a real increase in transaction time simply because they're moving more data across the network, and sometimes 2 or 3 times more data to complete a transaction authorization. So there's an element of complexity there just in terms of size to deal with. And then finally, as we complete the transaction, there's all sorts of interesting information in here that we need to look at to figure out what's going on and how it went. So there's the card service codes, which tell us whether a card is EMV capable, regardless of how it's processed, whether it's processed by the device as a chip or processed by the device as a magstripe. We can see different entry modes, whether the card is swiped, whether the card was chip first, swipe second, and then there's response codes that can tell us how the issuer responded to that particular transaction and what sorts of things they saw along the way. So that EMV transaction itself is a lot more complicated than magstripe, and there's a lot more opportunity for the various pieces and parts to not quite work together and to generate the types of errors that we saw in the last poll. So one of the things that we've looked at closely here at NetCo is what's between our customers and that peak EMV, where every transaction that should be EMV does go that way. And what we've seen is that there are 3 real key dimensions to this migration process. We deal with customers all around the world, customers in the UK and Canada where the EMV migration is largely complete, customers in the US where it's just getting going, and customers sort of all in between along the gamut. So we get to a unique view into where everyone is in this migration process and what they're seeing in different phases. So those 3 dimensions are terminals, cards, and transactions. On the terminal side, this really becomes a question of what percentage of your base is converted and is EMV capable. And obviously, if you control your terminal estate, this is one thing. If you don't control your terminal estate and where transactions come from, then this is a different thing, and you're more managing by influence to make sure that you've got people converted, or perhaps you're forcing them through certification or through deadlines or through other things. But we've seen this is a real challenge, getting that base of terminals converted, especially when you have to look at the age of the terminal. Can it actually handle the additional processing load, or do you have to do a full replacement or a replacement of a major chunk of hardware in the ATM case? You've got to get it configured right. You've got to get it certified. There's often issues to do with rollout. It could be as simple as the chip reader is not working properly or has a higher than normal error rate. Could be all sorts of things happening here. And then merchant education becomes a big part of the puzzle here as well, and making sure that merchants understand not only why they should be converting, but understand the dynamics of conversion and helping them figure out what parts of their estate to convert first as well. We're seeing a bit of a groundswell in the U.S. right now, for instance, where there are merchants who are just saying, yeah, maybe it's not worth the conversion. Maybe I should just, check signatures really carefully and watch my swipe cards list, and maybe I don't need to go to chip. And so some of those things, if you're sitting here from an issuer perspective, it's a pretty scary thought to think that some merchants may not come along for the ride, and primarily for cost reasons. The second element of getting to that peak EMV point is your card base. And it's not just how many EMV cards have you issued, but how many of your base are actively using EMV cards, and how many of them are actively using the EMV features when they do transact. Card quality is a bit of an issue here. You could certainly end up with a batch of cards that don't have great chips, but this really comes down more to consumer education and having the consumer get used to using that chip and PIN or chip and signature, inserting the card differently, perhaps waiting slightly longer for that local card authorization process to happen. But that's the other major thing that's between you and EMV is that consumer education and getting that percentage of your card base active. And then the third element is actually getting the transactions right. So doing those host software upgrades, I know for many of you that this could be a challenge. You're touching code that could be 30 or 40 years old, or you're perhaps interfacing new systems to old legacy systems, and there's all sorts of interesting issues and edge cases that can happen in that process that we've seen along the way, where certain cards from certain issuers work very well, but certain combinations of terminals and cards from different issuers don't quite work properly, and you've got all sorts of cases to handle here around interoperability and getting every moving part and every variation along that transaction path to work. And if you think about it, there are hundreds, potentially thousands, or even millions of different transaction paths you need to consider when you look at all the different bin ranges out there, when you look at on-us versus off-us transactions, foreign versus domestic, surcharge versus non-surcharge, different ATM models, different terminal models for point of sale. It quickly becomes a very complicated spiderweb problem around the interoperability side. And then the final thing that I think is the bogey on all of this is that notion of chargebacks and how you manage them. So you've probably got a process in place today on the magstripe side that's well supported by technology. Do you have the same process in place on the EMV side? And what we see is that a lot of customers have either tried to retrofit their magstripe process for EMV, or perhaps don't have the same disciplined systems and processes around chargebacks yet for EMV. And this is something that while you should expect to see fewer of them, you're still going to need to handle it. With that, I'm going to ask my second poll question here. So one of the things that we've heard as we've been out there working with customers is that EMV migration has made it harder to identify transaction slowdowns, failures, and anomalies. So I'm interested in whether you agree with this, whether you disagree with this, whether you're still trying to figure out what the experience is. And this sort of goes back, I'll let everyone vote. And again, remember the voting poll is available below your slides. So you may have to scroll down a little bit to see this. So one of the things is that as that transaction path is more complicated, there's more moving parts to think about in the process. You may have implemented EMV by retrofitting legacy systems or adding capability on top of legacy systems, and that creates another layer of interest and complexity in it as well. Okay, and I can see our votes just kind of rolling in here, so I'll let those roll in for a little bit. Strong portion of don't know here again, and that's, again, not unexpected. I think that there's still a fair bit of mystery around EMV transactions, where we thought very hard about the consumer experience, about the card issuing piece, but perhaps the element of really understanding what that means in terms of transactions and how we measure things. Measurement is often the last part of a project. We implement the functionality, we make sure that it's secure, and then finally we think about manageability as the last phase of the project. So for many of you trying to hit a deadline, it's most important to get that functionality first, and you sort of hope that you can keep a close enough eye on it long enough to get measurement and metrics in place. So what I'm seeing is that a large chunk of you either agree or strongly agree. Basically, the majority of people feel that EMV migration has made it harder to identify those slowdowns and failures. A good chunk, though, disagree. So that's good. That means that there's a number of you out there who've implemented those processes already and kind of see EMV as the same sort of thing as what you've been dealing with all along. And to some degree, it should be. You should be able to manage and monitor this in very much the same way as you monitor any other transaction. It's just a question of how you chose to implement. You may have made life harder for yourself, or you may have made life easier for yourself. And we'll talk a little bit about our view on that and how we can enrich that experience. Okay, I'm going to go ahead and stop the voting at this point. Thank you again for participating. What I'd like to talk about for the next couple of minutes is how NetCo can help. So how we've been working with banks, issuers, and processors around the world to provide a holistic view into your transactions so that there's 4 things that I've seen we can help customers do. One is deciding which terminals to migrate next. There isn't, for many customers, you may have migrated a good chunk of your terminals, but there's always a few out there that you're kind of wondering, is there a business case to migrate these? If you're in the U.S., there may be far more that you've got to migrate. So deciding which terminals to migrate, which ones to retire, how to handle that process. The second piece is all around that window that's been created, that window of opportunity that hackers are looking at to continue to exploit magstripes, and the creativity that we are seeing in that space. So being able to spot fraudulent usage at non-compliant devices or with non-compliant cards is all of a sudden becoming a very important part of the mix. And we think that you need to have some different mechanisms in place to handle that type of stuff today. Third is understanding fallbacks in detail. So this really comes to how do you hit that peak EMV point? You really need to understand where am I falling back and why, and gain really good awareness of that. And then finally, you want to be able to measure how close you are to peak EMV or how close you are to done is maybe a better way of putting this. So we'll look at all 4 of these areas. On the notion of terminal migration, the question really comes down to which location should I prioritize? So we're able to give you interactive dashboards here that help you understand not only where are your non-compliant machines located, do you have competitors in those areas that, for instance, could be taking EMV compliant transactions from you, and so that all of a sudden you're the only magstripe game in town, and that creates a risk for you. So those types of things are really important, seeing yourself in the context of other machines around you. Being able to understand the transaction volumes, the profitability of that terminal, what its behavior and usage patterns look like is an important feedback point. And then finally, understanding where your customers are and understanding whether that terminal still continues to serve a large base of your customers or whether it's a fairly small base of your customers, and being able to decide, do I want to continue to provide service in this location? And if I do I want to do it directly myself? Or maybe this is a good time to partner with someone else and do a co-branded ATM, for instance, in this location where that partner can deploy an EMV compliant ATM. I can still get a share of revenue off the transaction and provide a service point, but I don't have to upgrade and manage my own hardware. So we can provide you all the data and the visibility you need to start to determine which locations you should prioritize. The next element to look at is on the fraudulent usage side. So here, this is where we want to look at how that magstripe window is being exploited. So being able to see customers, for instance, that are being flagged for high-risk transactions. So we can see, are they completing more transactions than we'd expect a typical customer to do within a period of time in a geography? Being able to look at both their declines and their approvals. So where they may be attempting things and trying to see whether a card can be exploited potentially for a low dollar value transaction followed by a high dollar value transaction, things like that. And most importantly, being able to map these occurrences by location. So you can now correlate where are these transactions happening versus where are you EMV compliant or not EMV compliant, what times of day are they occurring at. So you can really start to see where are hackers getting creative in trying to exploit any sort of magstripe vulnerabilities that you have within your your broader estate, because keep in mind, this isn't just about your cards, this is about other people's cards and your machines. This is about your cards on non-compliant merchant terminals. There's all sorts of dimensions to this problem. And again, being able to visually see what's happening, frequency of transactions, et cetera, can really help here. Same kind of notion on the volume and velocity side, being able to see whether you have sudden increases in volume or transaction velocity at different points across the network can help you see whether there's a coordinated attack occurring, for instance, or whether there's a high number of magstripe swipes all of a sudden at a common point of sale or ATM terminal, where it may be that all of a sudden, for some reason, there's a lot more magstripe usage at a particular point in the network than there classically has been, which could indicate someone's trying to, again, take advantage of that vulnerability in the system. So the fraudulent usage pattern piece is all about understanding how magstripe is being exploited along the way to EMV. And keep in mind that we've invested a lot in EMV, so this is about how do we realize that return as quickly as possible by isolating these magstripe issues quickly. The third element is fallback detection. So this really gets at our peak EMV puzzle of how do you spot transactions that should go EMV that don't. So here you're seeing an example of a real-time alert coming from our system that shows the customer is using an EMV-capable card on what should be an EMV-capable ATM, but there's a fallback to magstripe. So this is something we're really going to want to investigate. This is one of those unusual interactions between two devices that should be able to handle this transaction. So are we dealing with a consumer education issue? Well, we could see that by seeing that the attempt was first made with chip and then subsequently with magstripe, but in this case, it looks like we're probably dealing with some type of technical interoperability issue that we would want to research and explore in more detail. Here, for instance, just an expanded view of this particular transaction that shows the card service code is a 226. So anytime the service code begins with a 2 or a 6, we're dealing with an EMV-capable card, regardless of how that transaction is processed. So this also allows us to keep score on how many cards, the other side of the EMV puzzle, which is how many successful EMV transactions are we executing. You can see this one was for $400. You can see that it was a Visa card withdrawal and all these different elements of it. And the last dimension we want to look at here is the measurement piece. And so I think we saw a lot of folks on the last poll not really sure whether EMV is causing more issues for them or not, and whether their error rates are increasing or not. And I think that fundamentally comes down to a measurement challenge, which is, and there's two ways that I look at measurement. The first piece is just, how do you spot sudden changes in your EMV magstripe mix? So how do you become aware in real time that things are shifting and usage patterns are shifting? Because this could indicate some significant technical issues. This could indicate some significant fraud-related issues within the fleet. So our system can actually track in real time. And I'm looking now at this chart down in the bottom here where the blue peaks tell me what my magstripe activity looks like. The violet or purple colored ones tell me what my chip activity is. And then the small green line is actually the manual entries. So I can see in real time the split between those three types of entry mode, and I can understand whether I'm seeing any significant variability. I could set a threshold that says, you know, if the mix all of a sudden changes from 70-30 to 60-40, I want to be alerted. And then finally, I guess the question that anyone who's embroiled in an EMV project has is, you know, how do I measure how close I am to done? This is a big high visibility project within a lot of banks and issuers and processors, and being able to really keep track of where you are and answer that question of, you know, how close are we to being done here? Where are we in the process is important, but also really difficult to do. How do you really report on how close you are? And so I think that this notion of peak EMV is a really important element of it, being able to measure of all the transactions that should be done as EMV, how many are done that way. That really shows you how successful your technical migration efforts have been. You know, and then you can measure that against that gap, which is how many are still being handled as magstripe and how is that shrinking. So on this dashboard, you can see on the top left there, you're seeing your actual magstripe transactions versus your actual EMV transactions, and then we can actually forecast that out. And based on how you've been doing, we can see what the trend looks like and what that split is expected to look like. Now, in this case, this customer's activity has been pretty flat, so it's not expected to change a lot over the course of the next few months, but you get the idea here. And down on the bottom, we're measuring peak EMV. In other words, based on those card service codes and everything else I showed you, what transactions should have gone EMV versus which ones actually did go EMV. And you can look at that gap and how you narrow that gap. And these, we think, are two really important metrics in your overall EMV migration effort. Now, I'm going to shift gears a little bit here. We've been talking a lot about EMV and how we can help here. I just want to very quickly stress in a couple of slides that our solutions are certainly far broader than that. So this EMV monitoring and analytics capability is part of a broader solution set that we offer for ATM and monitoring and self-service, for omni-channel banking, for analyzing your payments monitoring processes. And what NetCo delivers is two things: a set of innovative business applications for banks and processors. So whether you are in IT ops and primarily concerned with the customer experience and with response times and system performance, whether you're in channel management, mainly concerned with the customer behavior and understanding that, or whether you're looking at this more from a fraud perspective, we offer applications in each of those areas, and they're built on a single platform that actually can collect, analyze, and manage all this transaction data. So unlike a lot of systems that you may be looking at where their first question is, okay, we just need to get access to your transaction data and then we can do everything you want, our system actually comes with that access to transaction data. And I'll talk a little bit about the technology we use to do that, but we really are an end-to-end solution. So for the banks that we deal with, the real challenge here is that as we try to shift more transactions from human interaction to self-service, whether it's mobile or dedicated devices, we're generating a lot more electronic signals as that customer interacts. There's a lot more data being generated, and harnessing that data is a real challenge. And so what we're trying to do is help IT find problems before customers do, giving the channel managers that data to be able to make decisions based on fact instead of on feel, and being able to give the risk management group the ability to detect fraud before the damage is widespread, to see those attacks as they're unfolding. And our platform is designed to make all of that digital interaction data immediately and instantly and easily accessible to these various groups. So whether it's to support an EMV initiative, whether it's to help with magstripe fraud detection, or whether it's to help you figure out where best to place your devices, transaction data, we believe, is a real critical part of that recipe. This is the technology stack that we bring to bear to solve the problem. And one of the most unique things about our system is our ability to actually collect transaction data and act as a primary source of transaction data. So we are actually, our servers and our software will sit in your environment passively listening to network traffic. So all the different traffic that goes across the network, but picking out just the payments or the financial transactions you're interested in, and then actually reconstructing those transactions from the raw network packets. So the nice part here is you don't have to put agents on your devices or change your application code or somehow provide a data feed into our system. We can actually capture the transaction data directly in your environment. And that provides us a very unique advantage in terms of bringing together this rich transaction data, decoding it, analyzing it, and then giving you applications to interact with that data, whether you be on the channel, the fraud, or the IT side. So our customers typically benefit in three areas. On the IT side, they're able to reduce their support costs and resolve problems 65 to 75% faster. So that means that if it takes you today 8 hours to resolve a transaction performance problem, you have to figure out whether it's, first you have to be aware that it's happening. Second, you have to figure out whether you're dealing with an application, a network issue, a host issue. And then third, you have to get the right team focused on solving it. We compress that entire time scale by essentially giving you real-time visibility into those issues and who should be responsible for fixing them. On the channel management side, the benefits come in terms of improving the channel profitability, adding customer value, but really helping you understand how customers are behaving in your digital channels, giving you that visibility. And on the fraud side, it's about helping you mitigate fraud losses by giving you faster detection and better tools for seeing what's happening and what type of anomalous behavior is occurring in your environment. And last of all, who we are. So NetCo we're a private company. We're based in Canada. We were founded by financial networking experts, which is why we have this unique ability to capture transaction data off of the network and analyze it. And our customer base is global. We have installations in over 50 countries, and our customers range from smaller credit unions all the way up to major issuers, processors, and banks. And we talked a little bit in this presentation about how we can help you on your EMV journey. And what we've seen in our customer experience is that a holistic transaction view can help you decide which terminals to migrate next, can help you spot fraudulent usage at non-compliant devices, can help you understand those fallbacks in detail, and can help you finally measure how close you are to peak EMV and how close you are to done, and more importantly, report confidently to the organization where you are in this process so that you can really say, look, we've made a big investment on this and we are starting to see the returns. Here's where we are exactly in the process. Here's what we're trying to get to next, and really communicate more effectively. And with that, I'm going to open things up for Q&A. There is a chat function where you can ask questions. If you would rather not, and I'll answer those verbally here. If you would rather not, please feel free to email me right now or after the fact, and I'll answer questions that way as well. Okay, so the first question I have is, can you show a breakdown of transactions by interchange? Are you able to see the costs and revenues of each interchange connection? So this is a really interesting one, and I've seen a couple of cases now where when you go to a point-of-sale terminal, for instance, in the U.S. right now, and you use a debit card, you're prompted whether you want to use Visa debit or U.S. debit. And it's actually a decision between do you want to use signature debit or chip. And it's an interesting change that some of the processors have automatically pushed down to the devices. And it really confuses customers, you know, which one of these do I want to use? And of course, you remember Durbin made sure that we wanted to have that choice for customers. But in some cases, the choice has been given directly to the consumer rather than to the merchant. And as you know, whether you choose one of those options or another, you could be incurring a higher interchange or processing fee for the transaction. So all of that is a long preamble to saying, yes, we can show a breakdown of transactions by those different interchange dimensions. We can show which issuers you're routing to. We can see what the fee, help you understand what the fee structure is on those. And we can do that in real time or after the fact. And if that's an area that you're interested in doing more analysis on, that is one of the areas we are looking to build out an application. We're exploring whether that's an area where we should have a full-fledged business application for someone who's trying to understand interchange revenue and optimize it. So if you do have an interest in that, please do email me and let me know, and we'd love to have a further conversation. Okay. Next question. Is it possible to see a breakdown of transactions by EMV, magstripe, tap, and signature volumes? Yes, it is. We can be monitoring this in real time for you, or we can help you see this historically after the fact by looking at the entry mode for the card transaction. So we can absolutely see those breakdowns and help you understand not just what do they look like today, but we can forecast out based on the trend that you've been seeing, where should you expect to get to a month from now, 2 months from now, et cetera. Next question, why would a real-time transaction, here we go, sorry, real-time transaction data feed be better than transaction log files? So this question I think is getting at, I mentioned that we have a very unique way of capturing the data off of the network as opposed to accessing log files or getting a host data feed. The main reason is there's two reasons, really. Number one, all of your transactions do flow across the network, so we can be ensured that we're getting a version of everything. Secondly, we can see all manner of transactions, fragments, attempts, duplicates, things that might be, by the time they make it to a log file, may be expunged from the record. All those little glitches along the way we can see on the network. But the third point is, for a lot of banks, providing a transaction data feed is expensive, either in terms of the human cost of programmers adding that capability, or in terms of a licensing cost from your switch or application provider. And so, and it often takes a long time. It often can take 6 months to get a feed of transaction data flowing out of your transaction switch, whereas we can bring our system in and have it deployed within a couple of weeks, capturing that data off the network and actually capturing a richer form of that data. Okay, are we PCI compliant? Yes, we go through audits with all of our customers. We have a full security model in the product that conforms to the PCI guidelines around how we handle sensitive information and forbidden information and truncating card numbers. And I could bore you ad nauseum as to how the security model works. And we do have a full paper available on that for anyone who's curious. If you'd like to see that, please email me and I'll send that your way. Can you feed transaction data into various other fraud platforms? Yes, so we can feed data out of our system in real time into other platforms. We can do that in real time, or we can feed batches of data if that's more useful as well. So that's certainly something we'd be happy to explore with you if you have a use case around that. And again, if you'd like to email me directly there, I can put you in touch with the right people. Okay. Do you have any information on how many debit card are chip-enabled versus credit card chip percentage in the U.S.? I have seen numbers between 10 and 20% of the card base, which is obviously a pretty wide spread. I'm not sure. I think it depends issuer by issuer, bank by bank, how far along they are in that process. And I'm not sure what the split is between credit and debit. So I'm afraid I can't help you with the details there. That would be a good question for Celent or a Tower Group. They might have that data. ATM Marketplace may even be tracking it as part of what they manage as well. Okay. Let me just look at a couple of the other questions here. There's a question here about EFT acquiring processors not focusing on non-monetary transactions and trying to figure out whether chip is used. I'm not sure I quite understand that question. If you'd like to send a follow-up, that would be great. Or if you want to email me directly about that one, that would be great. I'm just not quite sure what element or what issue you're getting at here. But it looks like an interesting area, and I'd like to understand more about what you'd like to know. Question about how our system is different than various log analytics tools out there, machine data tools. So whether this is Splunk or Elasticsearch or others. Two primary differences. One is that our system actually does collect the transaction data directly off the network, so we have a way to acquire these financial transactions. Secondly is our system is real time. So we're not processing things in batches or waiting for things to come in. We're processing as they stream through. And third, we're very oriented specifically around transaction monitoring and analytics. So we're not a general purpose tool for bringing in log data from any source. We are specifically focused on transaction data. Now, if you're using a tool like Splunk or like Elasticsearch as your security information and event management platform, we can certainly flow our data and our alerts into that platform if that's where you're choosing to do a lot of that correlation work across various points in your network. How does the data gathering affect network performance? Very, very minimally, if at all. So the data gathering piece is that we're essentially using a feature that's built into most Ethernet switches called span ports or tap ports. And it's essentially sending a copy of the network traffic out another port on the switch. Switches, that's what they're designed to do, send traffic out ports. so it can typically be done with little to no overhead. 10 years ago, we used to worry a little bit about the overhead on the switch, and you used to see reports of 1 or 2% overhead on the network switch to perform this function. But nowadays, the switches are so fast that this is really negligible. And question, do we have customers in Europe? We do indeed. We have a number of customers in and around Europe, banks, processors, etc. Okay, and the final question here is, have there been any fraud attempts using chip cards? Is the number growing as more people use chip and PIN cards? This is a really interesting question, because I think that fraud attempts always go to the easiest possible area first. And so right now we've got magstripe still sitting there. It's vulnerable from a number of different ways. And all of the creativity and hacking attempt is going against that, because it's an easier mark and it's cheaper for a fraudster to attack that than it is to attack chip. Yes, there are vulnerabilities in chip. There's various security conferences that have looked at them. I'm not aware of much that I've seen in the field yet. I'm sure there are cases out there that are beyond the proof of concept phase. But I think until we get magstripe down to a tiny portion of our transaction traffic, we're not going to see a lot happen on chip. Personal opinion, stand to be corrected. I'm sure there are security experts out there who have a very different view on this and see the world differently. But I just look at it from the perspective of what's the easiest thing to attack right now. And of course, the ultimate is not just shift to magstripe, but a shift to card not present. Right? We're seeing that through mobile and online channels as being a really growing attack vector right now. So it's interesting. The fraud moves to the easiest point typically in the system, not the hardest point. All right, with that, looks like our question flow has ebbed, but if anyone does want to email me, please do, and I would be happy to answer your questions after the fact. Thank you very much for your time and attention today. We really appreciate it. I hope we've been able to give you something of value to think about, and I hope that as you work your way through EMV migration and see some ways in this presentation that we could help out, that you contact us and let us know. We're eager to help you in any way we can. Again, thank you very much, and enjoy the rest of your day.